My name is Stephen Gottlieb, and I made up the integrated algebra video for the New York State Regents. At this point, I would just love for you to sit back and enjoy a sample demonstration that I'm going to prepare. That way you get to see a little bit about my teaching style. But we get right into it. We want to simplify the square root of 72 minus 3 square roots of 2's. The first thing you need to know is the numbers that you know the square root of. And believe it or not, there's a lot of numbers you know the square root of. You know the square root of the numbers I'm going to put here. You know the square root of 4, it's 2. You know the square root of 3 squared. That is, you know the square root of 9, it's 3. 4 squared, 36. Let's try that again. 4 squared is 16. 5 squared is 25. 6 squared, 36. 7 squared, the number 49. 8 squared is 64. And 9 squared is the number 81. You know the square roots of all of the numbers that I have circled. Now what you want to do is find the largest number on our list that goes into 72 evenly. And no number bigger than 72 will go into 72 evenly. Now what about 64? Well, 64 times 1 is 64. 64 times 2 is above 72. So 64 didn't go in evenly. 49 times 1. But 49 times 2 is close to 100. After all, 50 times 2 is 100. That's not near 100. 36 times 1, 36. 36 times 2, look at that. It's 72. So the largest number that I know the square root of that goes into 72 is 36. So I'm going to write the square root of 72 as the square root of one number times the square root of another number. And one of those numbers is going to be 36. 36 times 2. The square root of 36, I know, it's 6. The square root of 2, I don't know. Nor can I simplify the square root of 2, because no number on my list goes into 32. If you want to say 1 squared is 1, fair enough. The square root of 2 is, well, 1 times 2 is 2. So it's the square root of 1 times the square root of 2. But the square root of 1 is 1. When I multiply it by square root of 2, I didn't get anywhere. That's why I didn't write down 1 squared. And like I just argued, you can't break down the square root of 2, so you can't break down the square root of 2. So we have 6 square root of 2's minus 3 square root of 2's. At this point, and a lot of students can get this far, but then they lose it. They're like, oh my, what's this? Now, most of those students would know that 6x minus 3x, the number is 3x. Well, x is just a placeholder for a number. You need to understand that at all times. It's a placeholder for a number. So 6 times square root of 2 minus 3 times square root of 2. 6 of these minus 3 of these, it leaves 3 of them. You get 3 square root of 2's. And that's the answer to this problem. Now, I really want to illustrate again what I kind of said over here. Most students will know that 98x plus 2x is 100 x's. But of those students, a lot of them would not know how to do this problem easily. 98 times 7 plus 2 times 7. They're like, let me go run and get a calculator. Or give me a pencil and paper so I can compute 98 times 7. You don't need to do that. This is the same as the problem above, except I'm just being nice and I'm telling you that x is the number 7. This is nothing more than 100 times 7, which is 700. Now, why is that true? Well, multiplication is repeated addition. 98 times 7, 7 times 98, is nothing more than 7 plus 7 a number of times. How many times? 98 times. Plus 2 times 7. That's 7 plus 7. 2 more times. Well, I'm adding 7 to itself 98 times, 99 times, 100 times. This is nothing more than 7 plus 7 100 times, which of course is 700. Okay, you should really catch on that just because we put numbers in, you don't know how to do it. Think what you would do with the letters. This completes the sample demonstration. Hope you enjoyed it. Hope you learned a little bit about simplifying radical expressions. And most of all, I'd like to wish you luck on your upcoming New York State Integrated Algebra region. And thank you for viewing my video.